In this video, we're going to go over the converse of a postulate, we're going to learn a new postulate, and go over the converse of 3 theorems that we've learned in the past 2 videos. Now remember that P implies Q is a conditional where the hypothesis implies the conclusion. So the converse of that conditional would be Q implies P, and that's the conclusion implying the hypothesis. So let's go over the converse of the corresponding angles postulate. The converse of the corresponding angles postulate, P13 in our case, states that if 2 lines are intersected by a transversal so that the corresponding angles are congruent, then the lines are parallel. Notice that this first half of the if statement, or the hypothesis in this case, is really the conclusion of the corresponding angles postulate, and the conclusion in this case is really the hypothesis of the corresponding angles postulate. And this is stating that if the corresponding angles are congruent, so A congruent to E, B congruent to F, C congruent to G, and D congruent to H, if those are congruent, then these 2 lines, X and Y, are parallel. Let's go over a new postulate, the parallel postulate. P14 states, if given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. Let me illustrate a new picture for this postulate. And I have a point not on A. There is only one line I can draw through this point that will be parallel to that given line A. So this would be line B. This is the only line through this point, let's say point P, that is parallel to A. There is no other line that I can draw through point P that will be parallel to A except for this line B. Same with X. If I was to draw a point below X that fell on line Y, Y would be the only line that's parallel to line X through that given point. Now let's go over the converse of alternate exterior angles, converse of consecutive interior angles, and converse of alternate interior angles theorems. The converse of alternate exterior angles theorem, THM, is short for theorem. T10 in our case, if 2 lines are intersected by a transversal so that a pair of alternate exterior angles is congruent, then the 2 lines are parallel. In our case, we have 2 lines, X and Y, that are intersected by a transversal Z, so that A and H are congruent and B and G are congruent exterior angles. Then X and Y are parallel. Again, notice that the hypothesis and the conclusion are switched for the alternate exterior angles theorem versus the converse of the alternate exterior angles theorem. Now we're going to go over the converse of consecutive interior angles theorem. The converse of consecutive interior angle theorem, T11 in our case, says that if 2 lines are intersected by a transversal so that a pair of consecutive interior angles is supplementary, then the 2 lines are parallel. So that's saying if two lines x and y are intersected by z, so that a pair of consecutive interior angles, C and E, or D and F, are supplementary, so they add up to be 180, then the two lines, x and y, are parallel. If the measures of angle C and E were 180, or the measures of angle D and F were 180, then x and y are parallel. Let's go over one more theorem. The converse of alternate interior angles theorem, T12, says that if two lines are intersected by a transversal so that a pair of alternate interior angles is congruent, then the two lines are parallel. So we have two lines, x and y, are intersected by a transversal z, so that a pair of alternate interior angles is congruent, meaning that C and F are congruent or D and E are congruent. Then, if that's the case, x and y, the two lines that were intersected, are parallel. And that is the converse of the alternate interior angles theorem. In this video, we went over the converse of the corresponding angles postulate, the parallel postulate, and the converses of alternate exterior, consecutive interior, and alternate interior angles theorem.